Hey guys, welcome to question MM450 of the Maths Methods Fortify study guide. If you've made it this far, congratulations. This is the very last question in the book. If you have made it this far, thank you for getting Fortify and thank you for using it. I hope you've really liked it. But for now, let's just jump into the last question and get you finished. So, this total question is worth 13 marks. We're going to start with just part AI, which is worth 1 mark. So, says a classroom of n students where n is greater than 21 undergo a survey to find out which pets each family owns. From census data, it is known that the probability of any given student owning a dog is 1 in 4. So let's just call P 1 in 4 for now. The random variable x is the number of students who own a dog in this particular classroom. What is the probability that none of the first 4 students surveyed own a dog? Awesome. So this is just a 1 mark question, as I said before. So we don't have to really show any working, but the thinking behind it is important. So if the probability of a student owning a dog is 1 in 4, that means the probability of a student not owning a dog is 3 in 4, right? Now, the probability that none of the first 4 students surveyed own a dog means we're looking for 4 students who don't own a dog, okay? Which means that the probability that the first one doesn't own a dog is 3 in 4. Probability that the second one doesn't own a dog is 3 and 4, and so on for all 4 of these. Which means that the probability that none of them own a dog is 3 and 4 times 3 and 4 times 3 and 4 times 3 and 4. Or 3 and 4 to the power of 4. Which means we get 3 to the power of 4 over 4 to the power of 4. You do have your CAS, so you can do this in your CAS if you want to. And what this spits out is 81 over 256. That is our first and only mark for part AI, guys. Let's move on to part AII. Part AII is a 2 mark question and says find the probability that at least 8 of the first 21 students surveyed own a dog correct to 4 decimal places. So, what are we dealing with here? We're dealing with binomial distribution, okay? And the way that we know that is because we have 2 outcomes, right? We have a success and a failure, where the success is them owning a dog, the failure is them not owning a dog, right? Because there's only those 2 options. They can't have any other, there's no other option. They can either own it or not own it. So we know that it's binomial. So, and it's independent of everything else, right? So one student owning a dog doesn't affect another one, which is another indicator that it's binomial. So we're going to get up our binomial CDF in our calculator, which I'm pretty sure is menu 55E, at least for me it is. And it's going to ask you 4 things, as always. So lower, upper, N, and P. So our lower, we're looking for the probability that at least 8 of the first 21 surveyed own a dog. So x is greater than or equal to 8, so at least 8, which means that our lower is 8 and our upper is 21, right? Because our n is 21, we can't have any more than 21 because it's saying the first 21 students surveyed. So 21 is n as well. And the probability that any student owns a dog is 1 in 4, right? The question tells us that. So this is our first mark. Subbing this into our CAS and clicking enter, we get 0.1299, which is our second mark. And that's it. So guys, if you have any questions about that one, let me know. Just make sure you have it in correct 4 decimal places because that's what the question's asking for. So that's it for part AII. Let's move on to AIII. So part AIII is a little bit weird. I can understand you not getting this if you had a bit of trouble with it, because it is one of those ones that you potentially haven't seen in a while. So again, this is a 2 mark question, and it says the standard deviation of x is root 78 on 4. Find the value of n. Awesome. So n is the number of students in the classroom, right? So we know from the start that n is greater than 21, so that's kind of a help, I guess. But the biggest thing is we know that the standard deviation is this, which tells us, because the standard deviation is equal to the square root of the variance. Okay, and you'll see why we're doing this in a second. Square root of the variance, which means that the variance of x is the square of the standard deviation. Okay, so it's the inverse of that. So squared, which means that our variance is 78 over 16. And the reason that we're doing this is because we know that this is a binomial distribution, right? They can either own a dog or not own a dog. And we know that the variance of the variance of a binomial distribution is equal to NP outside of 1 minus P. Okay, we know that. That's part of our, and if you don't know that, you do now. You've just learnt that. If you didn't know this, try pausing the video and working this out by yourself now. So we know that the variance is equal to this. We know that the variance is also equal to 78 on 16, which means that 78 on 16 is equal to, actually let me just simplify that. That's equal to 39 on 8, if we divide both of them by 2. So the variance is 39 on 8 equals n. We don't know what n is, that's what we're trying to find. So n multiplied by p, where p is the probability of owning a dog, so 1 in 4, times 1 minus p, which is 1 in 4. Which means that we get, this is 3 in 4, so n times 1 in 4 times 3 in 4, which means we get 3n over 16, which equals 39 on 8. This is actually our first mark here, subbing all that in. And rearranging all this, we get n equals 26, which is our n value. And keeping in mind that this should be a whole number because we can't have a decimal number of students, right? So this should come out as a whole number. If it didn't, you've done something wrong. So that is our second and final mark for part A, I. Guys, if you have any questions, please let me know. But for now, let's move on to part B. Part B is moving completely on from this section, so I'm just going to rub all this out. We don't need this anymore. And part B, or part BI, I should say, is a 2-mark question as well. So it says, if a student owns a dog, the probability that they go on regular walks each week is 5 in 8. If a student doesn't own a dog, the probability that they go on regular walks each week is 2 in 9. Okay. If a student is chosen at random, what is the probability that they go on regular walks each week? Cool. So as soon as we have these conditional probability things, we need to immediately start drawing a tree diagram, okay? Because a tree diagram is going to allow us to figure out what the different possibilities of this situation are. So, a person can either own a dog or not own a dog. If you don't own a dog, I feel sorry for you. They're awesome. If they do own a dog, the probability that they go on regular walks each week, actually, let's just start with this. If they own a dog, they can either walk regularly or not walk regularly. If they don't own a dog, same. They can either go on walks regularly or not go on walks regularly. Now, the probability that any given person owns a dog is 1 in 4. The question told us that, which means that the probability that they don't own a dog is 3 in 4. Now, if they own a dog, the probability that they go on regular walks is 5 in 8, which means that this tree here is 5 in 8, or this branch. The probability that they don't go on regular walks is 3 in 8, right? Because these two have to equal to 1. If they don't own a dog, the probability that they go on regular walks is 2 in 9, as the question told us, which means that the probability that they don't is 7 in 9, right? Because they have to equal to 1. Sweet. Awesome. Now, that is our first mark, essentially, here. And what we're looking for is the probability that they go on regular walks each week, okay? So they can either own a dog and go on regular walks, or not own a dog and go on regular walks. Which means that our probability that any given person goes on regular walks is the probability of dog and walk plus the probability of no dog and walk, right? Which is this pathway here. So we simply times these or multiply these probabilities together to get that probability. 1 in 4 times 5 in 8 plus this path here, which is 3 in 4 times 2 in 9. Awesome. Simplifying this, we get 5 on 32 plus 1 in 6. And this is equal to 31 over 96, which is our second and final mark for part BI, guys. If you weren't sure how I created this tree diagram, just hit me up and I'll explain it to you a bit more. But for now, let's move on to part BII. Part BII is also a 2-mark question and says, one student chosen at random goes on regular walks each week. What is the probability that she owns a dog? Awesome. So essentially what we're saying is, what's the probability that she owns a dog, given that she goes on regular walks each week, right? So what we're looking for then is the probability, because this is a given formula, right? And I think that would probably trip up a few people, is actually figuring out that this is a given question. But the formula is D intersect W over the probability of W, right? Now, to find the intersection between D and W, we simply take those two branches and we multiply them together. So 1 in 4 times 5 in 8 over the probability that any given person goes on a walk, on regular walks, right? Part BI, we found that that was 31 in 96, which means that 31 in 96 goes on the bottom. This is our first mark. It's pretty much like between here and here is our first mark. Like the recognition of doing that is a mark, and then setting that up is another mark, which means we get 5 in 32 over 31 in 96, which is equal to 15 over 31. That is our second and final mark for part BII, guys. Let's move on to part C. Part CI is a 2-mark question as well. I'm actually just going to rub all of this out because I don't think I need that anymore. Hopefully not. No, I don't. Cool. And part CI says, it is found that a few of the students own Jack Russell dogs. Let Y be the normally distributed random variable which defines the weight of a Jack Russell in kilograms. Y has a mean of 11 and a standard deviation of sigma. So we don't know what the standard deviation is yet. 42% of Jack Russells are heavier than 11.5 kilograms. Greater than 11.5. Find the value of sigma, correct to 3 decimal places. Awesome. So we know that it's normally distributed, so we can do a normal distribution curve. We know that our mean is 11. We don't know what our standard deviation is, but we do know that 42% are heavier than 11.5. So at 11.5, 42% are heavier than this, which means that in order to find our sigma, we're going to need to use our formula z equals x minus mu over sigma. So whenever you need to find the mean or the standard deviation, we need to use this formula and follow this exact same process. It's the same every time. So we know our x value is 11.5. We know that our mu is 11, but we don't know what our z value is. And we're going to need that to find our sigma. So in order to find our z value, what we're going to do is use our inverse normal. Okay, so we know that we need to use our inverse normal because we know our probability, we know our area, but we don't know the value that it occurs at. Okay, so everything from here is 42%. Inverse normal, which I believe is menu 553 or menu 552, something like that, is going to ask us for 3 things: area, mu, and standard deviation. Now our area is, in inverse normal, we always have to take the area to the left. And if you're on this last question, I'm sure you recognize that by now. Which means that if everything above it is 42%, everything below it is 58%, okay? Which means that our area is going to be 0.58, because that's our 58%. Our mu is going to be 0, and our standard deviation is 1, okay? Because we're looking for our z value, which is how many standard deviations away from the mean we are. Now this is going to spit out an answer of z equals 0.20. I don't know why I put this many decimal places in the work solutions, but I did, so let's just go with it. Z equals 0.201893, which is 1 mark. And now we can sub this into here, right? So we know our Z value now, so we can say that 0.201893 equals X, which is 11. Sorry, 11.5 is our X value, because that's the point that it occurs at, minus our mean, which is 11, over our standard deviation, which is what we're trying to find, right? Now, rearranging all this, we get sigma equals 0.5 over 0.201893, which equals 2.477 kilograms, and that is correct to 3 decimal places, which means that that is our second and final mark for that part, and that's it. So let's move on to part CII. Part CII is, again, a 2-mark question, and we're still dealing with the same context. So it says, find the probability that y is less than or equal to 13, given that y is greater than or equal to 11.5. Now, we know that this is a given formula, so we can say that our given is y is less than or equal to 13 intersect y is greater than or equal to 11.5 over the probability that y is greater than or equal to 11.5. Right, that's just our generic given formula. Now, the intersect between greater than or equal to 11.5 and less than or equal to 13 is between 11.5 and 13 over the probability that y is greater than or equal to 11.5. Awesome. Now, we know that the probability that y is greater than or equal to 11.5 is 42%, right? The question told us that 42% of Jack Russells are greater than 11.5, so that's an important recognition in itself. So this is 0.42, but we don't know what this is. So what we're going to do is we don't know our probability, but we do know our n values, which means we're going to use our normal CDF. So normal CDF in our CAS is, I think, menu 553. Let me just confirm that. Menu 552. Menu 552 is normal CDF. And it's going to ask us for 4 things, as always. Lower, upper, and mu and sigma. So mean and standard deviation. Now our lower bound is going to be our 11.5. Our upper bound is going to be our 13. Our mu is going to be 11 because that's our average, or our mean, I should say. And our sigma is going to be our 2.477, right? Because that's what we found in the previous question. This should spit out an answer that says between 11.5 and 13 equals 0.2103, which is our first mark for that question, which means that this given formula here is 0.2103 over 0.42, which gives us an answer of 0.5007, which is our than 13, given that y is greater than or equal to 11.5. And this is our second and final mark for part CII, and that wraps up MM450, which wraps up this whole entire book. So guys, congratulations if you did make it through all of these questions. If you have done all of these questions, you're going to smash your exams. It's just a fact. By this stage, you should be really, really confident with all the sort of questions that are in the exams. And hopefully you've enjoyed Fortify. If you have any feedback for us, please hit us up on our Facebook page or our website. If you liked it, please consider just letting us know what you liked about it and all that sort of thing. But thank you so much for joining us on this journey, guys. I won't see you in the next video because there will be no next video. But thank you very much for watching all of these. And I will see you later. Thank you very much, guys.